Dr. Timothy Young. He's a professor in the Center for Renewable Carbon at the University of Tennessee. He has a PhD in statistics with a focus on natural resources and an MS in statistics, which is focused on operations research from the University of Tennessee. He also holds a master's and master's degrees from the University of Wisconsin in Madison. He's taught highly successful industry courses in advanced analytics and data mining, process analytics, statistical process control, lean methods, and design of experiments for R&D and manufacturers to more than 1,000 industry personnel, which includes me, as a matter of fact, since 2000. His current focus areas in the data sciences are advanced analytical modeling of processes, machine learning and AI applications, data fusion and data quality management, statistical visualizations, real-time predictive analysis, and real-time statistical process control. He's 4 years of manufacturing experience with Georgia Pacific Corporation. He's participated in grants from private and public sectors totaling more than $32 million, and he has successfully mentored more than 29 master's and PhD students combined. Dr. Young has 304 scientific publications, of which 98 appear in reference journals. He's given more than 400 professional presentations and has been invited keynote speaker at 20 scientific meetings. He was a Fulbright Scholar and a Fulbright Specialist in 2014 and 2016 in Austria. Tim was awarded the University of Wisconsin's Outstanding Alumni of the Year in 2018 and Fellow of the International Academy of Wood Science in 2019. He's current head of the Industrial Engineering Unit and Director of the Center for Data Science and of the Athens Institute for Education and Research in Greece, and he is actually in Athens, Greece at this time. Leadership experience includes, he was a past president of the Forest Products Society. He's also an active member of the American Statistical Association and Forest Products Society. So it is my pleasure this morning to introduce Dr. Tim Young.
Okay, thank you, Terry. That you didn't have to read all of that, but thank you. Yeah, glad to be with you today. Can everybody hear me? Thumbs up. Yeah, okay. So let me do my little share screen here. And we see the presentation. We see the presentation, yeah. Yeah.
Seeing it now, yep.
You see it now? Okay, thanks. Scott Levengood, yeah, good to see you. So let me here and we'll get going. So yeah, this is a little bit of a transition from our previous talk. Definitely a transition for us here, but it was very interesting talk on wood pellets. Always had an interest in that. So I guess there is a little bit of overlap here when you talk about quality and meeting specifications and improving processes, what I'm going to talk about today. And the bottom line is it's kind of fun in the world we live in now with virtual reality. I put a little splash screen of the amphitheater in Greece. So it's kind of neat that we can give keynote talks from around the world. As I'm putting 2 back-to-back conferences over here in data science and math statistics, and they're going to be hybrid models. So I'll be really interested to share that with the Forest Products Society, how that goes. So in this era of, I guess, smart manufacturing and predictive analytics, this is just a little intro slide, a couple of intro slides here to really just indicate that you all know these folks. You know Jeff Bezos, you know Elon Musk, FedEx, of course, Steve Jobs, and they wouldn't be where they are today if it wasn't for the era of data science and that whole evolution. And you know, the theme of my talk is where is that going with this industry? And I hope to shed some light, at least from my experiences working with companies and talking with people that work in the industry. The AI learning rate, it's here. AI is here. You'll see a slide coming up, Generation Alpha, that's middle schoolers and high schoolers now. AI is their reality. They've never existed in a world without social media or AI. And as we know, AI manipulates social media to optimize essentially contacts. So Many believe AI has crossed human learning rate exponentially. These are older slides, but many believe we've already crossed that. And so how does that impact the theme on my talk? Well, a lot of you've heard about Industry 4.0. It came out of Germany. Industry 4.0 was this concept, I guess we call it big data here, and data science, predictive analytics. Industry 4.0 is this concept of the manufacturing system being a cyber physical holistic system, okay? So where essentially machines and robotics and software come together to essentially use algorithms and AI to run the processes. I'm not aware of any bio-based products industries that are there yet. I believe some are pretty well entrenched in Industry 3.0, as you see some of my slides, where we're using automation kind of on individual basis throughout the processes. So what's interesting is I put this little circular bioeconomy slide in here, and I think you're all very in tune with that. And what's interesting here is Generation Alpha and Generation Z really view products based on their environmental footprint. And Industry 4.0 and AI and predictive analytics, data science, whatever we want to call it, can really help some of these circular, economic friendly, bioeconomic products that are not cost competitive at this point become cost competitive by reducing variation and lowering costs. So the real-time world of the data scientist, this actual screen right here is from Chevron Corporation. They have the blue collar worker, they call it the white collar worker, and this is called their gold collar worker. They put essentially bachelor's level chemical engineers that run their control rooms, and not really meant to visualize a lot, go through these slides as far as being visual, to go through them in detail. But the idea here is to illustrate, this is a regression tree and predictive analytics. This person will require some knowledge of data and data analysis and statistical tools and machine learning to be able to interpret all this information. So where does this industry exist today as far as the bio-based industry? I put this up here, probably everyone on this call maybe has watched the movie Moneyball. If you haven't seen it, it's one of the assignments I give to my industry classes that I teach. But it's about it's a true story about baseball where statistics and probability essentially reformed people's biases about how to play baseball, where they use data and correlations. So it's a great movie. And I guess I pose the next question where we are relative to this talk. Are machines better at manufacturing than people? The human error factor, okay? The demand for data scientists continues to grow exponentially here. And so what are we going to do to meet that demand, and where does your companies exist in that realm? So before I give some examples about the industry, we do have a shortage of data scientists. And I know that even exists in this industry, the bio-based forest products industries, because of the contacts I've had and the requests to hire data scientist type individuals that will work within this industry. So it's a real challenge, I think, and this goes back to the academic people that are on the call. How are you going to change your curriculums to be, I guess, fill this gap for data scientists, especially as our industry tends to expand and the need for these type of people with these type of backgrounds. So what is a data scientist then? We've talked about data scientists. What is a data scientist? I like this Harvard Data Science Review, the study of extracting value from data, okay? A lot of companies collect a lot of data. This industry is very data rich and knowledge poor. And essentially there's a few hurdles they have to get over to become a little bit more knowledge rich, so to speak, okay? And the bottom line here in my slide at the bottom, or my content at the bottom here, it's really challenging universities now in all disciplines. So we're not talking about computer science, business, it's all disciplines. And I sat on a committee at the University of Tennessee where we offer a major and minor in data science now for all degree programs, all colleges, all departments. And so it's just encompassing redefining of academia to meet this need. So we have to adapt quickly, and academia is not good at adapting quickly. Curriculums have to go through very lengthy reviews. Typically for a state university too, they have to go to a state review board. And so we're, I guess, falling behind a little bit in our ability to adapt for industry needs. So what are the necessary skills? I believe data scientist or someone you hire, you're looking for that. Well, there was kind of interesting three categories: a data engineer, a data analyst, and a machine learning engineer. And I'm not going to go through this list, but you can see there's a little bit of a difference here in their qualifications. I was on a call with an executive from your industry yesterday when I was sitting in the airport waiting to connect. And we had a very nice discussion. And I found it very interesting that they brought up the fact that, and this is an executive person in your industry, they brought up the fact that we don't have chief data officers like other industries. So we struggle with all the data elements are organized at the plant level and by IT oversight. And what that creates is just this very large, unbalanced system of different software systems, et cetera, at the plant level. And then how are you going to get over that to go to a higher learning data science, predictive analytics level? A couple automation examples here. Application of data science, it's here and it's moving forward. We're behind other industries, but it's moving forward. And these are the ones I was allowed to share. There's others I'm aware of that I could not share due to NDAs, et cetera. But robotics in the warehouse is a big one. Kindel's using that in Salzburg, Austria. They did move to automated QC testing, which I have a slide coming up on that. They have real-time time and motion studies going on with their robotics. So they're trying to teach the robotics in the warehouse typically to learn. Okay, so they're trying to use this data to essentially make the robots learn about time and motion and wasted time and energy in that case. Egger is trying to do this completely fused databases across all mills, across the entire company. And they want to get to predictive process analytics, and they're based out of Austria. I do believe they have a new mill in North Carolina, MDF plant. And Norboard Europe, I'm going to finish with that. They started with a very simple concept called the daily variance report and 6 key metrics. So they wanted to walk before they run, and I'll highlight at the end. So if you haven't seen these in the wood industry, I believe I have not been in a plant recently that does not have an automated packaging line where robotics are being used. Obviously, robots are doing a lot of work in warehouses, distribution centers. I see them on production lines in plywood, essentially replacing defects. And the bottom line here is labor costs, and we all know this post-COVID era here, are increasing at an increasing or just steadily increasing, okay? Where robotics costs come down, or continually come down. So I guess I pose this questions to the audience to try to get a little discussion at the end, but will a robotic forklift make the same mistake twice? Okay. So again, that human error factor. This is Kindle. They're trying to reduce wasted motion and time and energy by essentially having smart robots learn and using the old-fashioned lean concept, but in an automated sense, using spaghetti diagrams, which is a very old-fashioned Toyota production system concept, but they automated that to essentially create smart robots in the warehouse. Automated QC testing, I had an example, Kindle's going to that. It's more popular in Europe. And these would be considered very simple machines, Industry 3.0, relative to Industry 4.0. But the bottom line is, again, the machine is doing all of the testing. And I don't know if Bob Breyer is still on the call. I saw his name earlier, but this is his slides at the bottom. He said I could use these a while back. And he did a study just looking at the human error impact on internal bond or tensile strength. And this must have been MDF, medium density fiberboard. And he did a controlled study where essentially there was this tremendous difference, 20, 30, 40 PSI, just by not keeping the blocks clean that you do the tensile strength test on. So he did different wedges and different gaps in these in the blocks, and just the human error factor then. Would a machine have cleaner blocks than humans? Additive manufacturing, oof, it's all the rage right now. It's really making a tremendous impact on our society and in our industry. There's being more and more publications. I've seen more and more publications coming out that are being published where machine learning is being used in additive manufacturing. This was a cellulosic fiber example where they're doing workflow of graded samples through sensors, and they're using machine learning to essentially optimize that system, as well as the really cool thing they were doing is they're doing machine learning to optimize stiffness at local scales and patterning that across the global scale. So in the additive manufacturing process, there's a feedback loop to machine learning algorithms. And that's actually one of the themes of the talk over here in Greece, one whole session's on machine learning. But that's really starting to revolutionize our whole ability to get to Industry 4.0. And then how does it impact R&D? Optimization, just some simple tools, but yet such as response surface methodologies, exploring interactions, but then going to tools like I know Dr. Lyles is very interested in, such as EVOP, and trying to automate EVOP. So again, back to the data science theme, how well are our employees equipped, okay, and their training and backgrounds to actually take advantage of this exponential growth in algorithm, computer learning, etc. And then also another example, response surface modeling for, this goes back to my circular bioeconomy slide, where this would be trying to optimize lignin yield, okay, through a separation organosol fractionation process, where response surface methodology was used to optimize or maximize the lignin yield. So I thought that was another interesting example of not machine learning, but using more statistical based tools. So then back to the foundation. And for those of you that know me that are out there right now, it's all about the data, it's all about the data, it's all about the data. This is the hurdle, I believe, that the forest and bio-based industries face right now. They collect a lot of data, they struggle with getting it fused, and these could be mills, not companies, okay? Plants within a company. How are they going to fuse this data when all of these are different, okay? And they're not managed by a oversight or planning level above them. So they can never really even get to data fusion. And when I'm talking about data fusion, I'm talking about fusing lab data with sensor data or modeling your process or whatever. They're really struggling here, and they're stuck right here for the most part. There are some companies moving ahead that I cannot talk about, but they are moving ahead, and they're integrating this data here to get to a higher level of predictive learning. And that's really the Achilles heel right now. And I don't know if that's ever going to be solved in the near term as an industry. But it was interesting to talk to an executive yesterday that's interested in chief data officers for your industry. And the bottom line here is that this is the previous slide, the data fusion slide here. Some elementary concepts like time lagging and things like that have to go on. But IT should not be a barrier to progress. IT people, I'm not against IT people, they're great people, but they should not be a barrier to communication. I understand the need in the world we live in to have high level security, but in a lot of companies, they can't get past here. IT still has become a barrier to even getting to data fusion. So real-time predictive analytics, where's the weakest link in our industry? And I don't want to come across as that I'm being real negative about the operator. They're very good people, very smart people, excellent people. I know, met hundreds throughout my career, but they just don't have the background and training. Typically, they come up the way the organizational structure is, the human resource structure, they come up from the plant floor and work their way to the highest level hourly position within the plant. So Chevron went beyond that, okay? So I think this industry, the first step even before data fusion and exploring that, we need to rethink the role of the operator, okay? Plus, it's an antiquated term. They don't operate machineries, they click a mouse. And so what information are they getting up here and what are they looking at? And I've had several instances lately of operators telling me they're putting too much information in front of me. Well, I find that fascinating because we're overloading them with a lot of analytics, but then we go away and is the operator really using that information? Okay, so how can we better equip the operator to be a data analyst of this good information, of its excellent information from which we can improve our processes? The human error, this is the third time I've used this kind of quote here. Would a robot change the set point at shift change? One of the things I've faced my whole career, and I do this kind of wild font here for shift change variation, and this is a slide that one of my students from industry came to my courses and brought in, and this is shift change right here. And the operator said he was a younger individual, engineer, started with the company, and the operator says, that's just the way I run the equipment. Would a robot have made that change? Okay, and then go back. And right here, the variation is greater, okay, right in this zone right here. So would a robot change the set point at shift change? And then let's not forget system reliability. There's a lot of work going on here. I think it's a very big component of predictive analytics, as well as influencing the variability of the product and the entire system. And one frustration I've had over my career is maintenance and reliability generally does not communicate. We have these silos within companies kind of, and maintenance kind of sits over here. And how often do they really talk about the data program or the predictive analytics program or anything like that? Where do they fit in this model? They've kind of always sitting over here, and we need to incorporate them. And this is really a reliability block diagram, a simple concept that came out of the 60s in rocket design, but it's alive and well. And how do we incorporate all of this information into our program in data science to try to focus on sources of variation that influence the cost of the organization? And let's walk before we run. This was all I was allowed to show from this daily process variance report that they use, variation sum report. It wasn't my idea. I helped them put together the statistical, I guess, methodology behind it. And what they did is, you know, and a lot of you that work in companies out there, you go to morning meetings or weekly meetings. We talk about quality, we talk about productivity, we talk about safety, we talk about environment, okay? We talk about human resources. But how often do we talk about variability? So this company made quite a leap ahead. So in their morning meetings, they were going to talk about variance of the, I think it's, I can't know how many are up here, but there's about 9 critical elements here, 9 or 10 critical elements. And then they track it. So it's on one sheet, goes out every morning. And then the other side of the sheet is emailed out is a control chart for the critical component with the most variability change, either improvement or reduction. And they have a more detailed report, but then they use statistical process control to see, are we getting better? That plant manager said he believed they saved $1 million British pounds the first year of implementation of that, because it got them focusing on variation and then in a preventive way also. So conclusions then, because I hope we get a little discussion. You know, data science for smart manufacturing, machine learning, that's another talk. I can give a very detailed talk on machine learning. I'm doing it over here because we have almost a half a conference focused on that. But I believe for the forest and bio-based products companies, it's a new competitive advantage. It's really your new competitive advantage. And I think companies that are moving ahead, that's starting to look at their data systems and looking across mills, if they get their data in a format, in a relational format, they can really start taking advantage of some of these concepts. And then data science, it's all about rapid innovation in R&D, because I know there's academics on this call, as well as people that work in R&D in the industrial sector. How can we use data science for rapid innovation, okay? EVOP, robust product design, those type of concepts. AI is now a reality in the business world. And a lot of you are really, some of these companies are moving ahead. You do have some AI applications in your marketing groups, in your sales groups. But my fourth bullet point here is the workforce of the future equipped with the necessary skills for the future. Kind of that section of my talk, I had a few slides about our curriculum, and that's back at the academic folks in the audience here. Are we really changing our curriculum? And Generation Alpha, they're here. They've never grew up in a world without social media. AI, and I read a very interesting article, that's people in middle school now and high school. They will have trouble distinguishing between reality and AI, okay? I think that's very, very interesting as you hire those people into the workforce. And then finally, I close it out. It's all about the data, total quality data management programs. I hope companies are moving forward with that. A lot of companies outside this industry are using that also, especially some of the food-based industries that I work with. For the students, if you never failed, you've never tried. I'm not going to go through this, but never stop believing. Michael Jordan, you know, was cut from his high school basketball team. And look what happened, what a success he was. Some references. And then a little quote by Taguchi, the keys to able to detect the signal from the noise. And I'll open it up for questions at this time.
Thank you, Tim, for really informative discussion. I do have a question. In terms of plants moving more and more toward automation, recently we've seen these incidences, particularly like with the gas line, where these ransomware situations occur. Do you think that's going to have any impact on that? Are people going to be concerned about those type of scenarios? I'm just curious.
Yeah, it's a great question, Jerry, because I'm hoping IT doesn't. my worry is IT is going to get, the walls are going to get bigger for security reasons, and let the walls get bigger around the organization, I guess. And IT in this industry is either going to have to subcontract out or hire individuals that are specialized in security. And some of you have that already, but you're gonna have to enhance that component because yeah, that's a very interesting hypothesis that due to computer hacking, system hacking, that it actually makes us regress. And I didn't think about that. Good question.
Another question is, do you have examples of companies that are doing a good job training employees to understand the real-time data, charts, et cetera, from process control systems? Scott Levengood said that his experience is those systems are largely magical black boxes that operators ignore. QC people come by to check them once or twice a shift.
Good question. Scott and I have known each other decades now. Yeah, I mean, I have so many examples where they put analytics or even statistical process control in the control room, and the operators don't know what they're looking at. So Scott, you and I kind of walk the same road here, and yeah, it's a big issue. We're not doing enough training, and I don't know why that is, because I see that ebb and flow throughout my whole career. All of a sudden, I get a lot of interest, and then it'll fall off. And I'd be interested, Scott, on your thoughts on that.
Scott, you have some thoughts you want to share?
Oh yeah, absolutely. Yeah, thanks, Tim. Yeah, funny. I've seen the same thing as you. When I started with OSU 27 years ago, I was offering SPC courses to industry, and there was zero interest. And then all of a sudden, people are asking me for it. I'm like, well, this is weird. And then there was a big, that, like you said, the ebb and flow. There's interest, and then it wanes again. But I think one big thing we have to overcome is just that math phobia. I've done 8-hour workshops where I had one formula on a slide, and I've had the feedback was not practical, too much math. And I'm like, my gosh, it was 8 hours and I had a formula for the average. That was the only thing that I showed. And yeah, people are going, this isn't practical. How do we convince them it's very, very practical and useful? I'm still working on it. Yeah.
Yeah, I mean, I turn off a lot with my formulas up there. But if you can't calculate something with a piece of paper, simple formula, I don't think you understand it. For the students out there, if you can't do a derivative or integral, I don't think you understand it. So, and if you can't calculate a mean by hand or a median with a simple data set, so but I agree with you. And I don't know. I haven't really looked at the futurists. I know in the US, we're way behind in education in math and science compared to other countries. That worries me a lot. So.
Dr. Breyer has a question. He says, is the issue the operator had was too much data or the wrong data or how it was presented?
Who was that from, that question?
Dr. Breyer.
Oh, Dr. Breyer.
Bob,
What was the question? They have too much data?
Ask you the question, Bob.
basically you talked about the operator having all that data in front of them. And the question I had is it, do they have too much data? Do they have the wrong data? Or how it's presented to them is not good enough for them to be able to digest?
Yeah, you know the answer to that, all three. We throw a lot of data up there, and you've been in control rooms, just like a lot of people on this call, and they say, well, those are Bob's charts. That's Bob's screen. Nobody looks at that screen. That's Bob's screen. He put that up there, and nobody told it what it does, you know. But so I've seen instances like that, all the above. So let's keep it simple, okay? But and I don't want to come across that I'm, you know, beating up on the operator, because I'm not being negative, okay? But because I've ran into highly intelligent operators in my career. The bottom line is, though, we're doing all this advanced stuff, throwing it at them, and we're not doing any training, back to Scott's point. And then do we need to rethink that role? And Bob, I thought you loved that, the block diagram, the dirty blocks, you know, data quality.
Well, our time is up. Dr. Young, thank you for the excellent presentation. Hope you have safe travels during your trip, and we'll move on to the next speaker.
Thank you very much.